Thank you, everyone. Can you guys hear me in the back before we get going? Yeah, cool. I wanted to thank Pete and Julia and John and the Geek Talk team for having me here. Thanks eBay for hosting. Thanks everyone for coming. Hopefully I can answer some of those questions about which workflow engine you should use if you're just getting started. Before I really get into things, I just wanted to go through a few pieces of background to make sure you guys know that I know what I'm talking about, even though that might not be true. And make sure we're all on the same page about, what is Hadoop, what's a workflow engine. So real quick, my background is that I've been working with Hadoop for about 4 years now, and I've implemented a Hadoop stack at 2 different companies on the DevOps infrastructure side, maybe what you would call data engineering. And over those couple of years, I've worked with a bunch of different systems, including Apache Uzi, Luigi, and the initial version of Azkaban. Those are 3 different workflow engines. So I've really seen what's out there. I've done some contributions to some of the workflow engines, and hopefully I can give everyone a really good overview of what the pros and cons are of the different systems. So I wanted to make sure that we don't need a real deep understanding of what Hadoop is, but I just wanted to make sure that we had a kind of basic idea. There are 2 parts to Hadoop. First is the distributed file system, HDFS, which basically distributes your data across all the nodes in your cluster. And the second part is a computation framework. In Hadoop 1.0, it's called MapReduce. And Hadoop 2.0, it's also called MapReduce, but it runs on a system called Yarn. Not super important, but basically Hadoop is a way of farming out computation and counting a lot of things really fast. A workflow. So a workflow is basically a list of steps that you want to perform, and you want to perform them in some order. So for example, I might want to take a dump of my production databases, put them in HDFS. So that'd be step 1. Step 2 would be run a MapReduce job to, say, clean up the data. And then step 3 might be a whole set of operations that run in parallel to, count the data one way, count it another, filter it, count it. So you're basically mapping all these different operations, and you represent the workflow as a DAG, a directed acyclic graph. And then a workflow engine is basically a system that manages workflows. It lets you create workflows, define workflows, run workflows, delete workflows, those types of operations. So to give you an idea of what a workflow might look like, I want to walk through 2 different use cases. And I think these are really representative use cases that pretty much everyone using Hadoop is doing one of these 2 things. So the first one is kind of an analytics data warehouse built on Hadoop. That is, you're ingesting a lot of log data. These become your fact tables. You're taking backups of your production databases, and these are becoming your dimensions that you join with your fact table. So your log data, let's say we're Amazon. Our log data might be things like user viewed a product, user bought a product, and you're going to just have a user ID in the log data, and then you would have a database backup that you imported into your system that would map a user ID to a full user object that has all the attributes you know about a user. And then from here, you take your log data, which is your fact table, your dimension data, and you can do roll-ups. So you might want to compute things like how many, for each product, how many users have viewed that product, and maybe you want to break it down by geography. So you roll up your data, you count per user, per state, per user ID, per state, per item ID, how many people have used it, and you would have all these different combinations of counts, and you would then load this into some low latency store, and then you would power your dashboarding and BI. So this could be something like, simplest case, I just want to count how many users are on my platform. More complicated, I want to draw pretty graphs that show me, which states are the most active, which products are selling well in which states, that kind of thing. And if you're more of a visual person, this is my cheapo drawing of what it would look like. On the left, you're taking your log, your DB dumps, putting them into Hadoop, and then you're running your compute, your MapReduce jobs that are aggregating the data, storing it out to your file system as roll-ups or cubes, and then you have some sort of export process that takes the data to your analytics database, and then your Tableau, your Teradata, sorry, not Teradata, your visualization software is connecting to your analytics database to power dashboards real time. And the reason you have that analytics database in there is that the MapReduce framework is not fast enough. It's not low latency enough to actually power anything that a user wants to view. And we're seeing a lot of activity in the Hadoop ecosystem to get rid of that last step that pulls data into an analytics database with things like Impala, the Stinger initiative, Adapt, all these different SQL on Hadoop implementations. So if you're a data engineer, what you should probably be asking yourself is, what happens if there's a failure in this pipeline? So there's a couple of ways you can have a failure. You can have a total failure where step A ran and it failed, and nothing else downstream ran from it. You can have a partial failure where it ran, but it only ran over a portion of the data set. So now everything downstream from it is bad. So like, for example, let's say you're in 2 data centers and you only actually got the logs from one of the 2 data centers. So all your counts are off by 50%. And the third type of failure, the third main type of failure is just that it didn't run at all. And maybe that was because the data wasn't there when it was supposed to be, or the system that is controlling what ran failed and no longer exists, or something like that. Second use case I want to talk about is Hadoop, what I'm calling Hadoop-driven features. So people you may know, which is what LinkedIn has, and gives you a list of like who it thinks you should connect with, is one example of this. Also, if you go to Amazon, they'll show you on the homepage, hey, we think you should buy this because you bought that. Those are 2 types of like collaborative filtering. And then there's another class of like machine learning where you're doing things like spam detection or natural language processing. And it's a similar but not altogether the same pipeline. Instead of putting your data in an analytics database, you're usually loading it to some sort of low latency, scalable, sharded database, often a key value store. So again, if you're more visual, this is what it tends to look like. You maybe are pulling in some log data, but oftentimes you're just pulling data directly from your database dumps, and you're doing more expensive calculations in Hadoop. And you generate these production data sets that then get loaded to your production data store that serves traffic to the production application. And in this case, it's a little bit different. What happens if it fails? A lot of times it's okay to skip a day. So if the people you may know recommendations don't get updated for a day, maybe some people don't see stuff, but it's probably not the end of the world. It's not like you're telling, in the analytics, data warehousing side of things, it's not like you're telling the CEO that the daily actives are half of what they should be. It's just you're breaking one feature or you're just making one feature stale. And a lot of times these workflows tend to be self-contained. So you don't have a whole lot of, you might not chain a lot of them together. If you're calculating friend recommendations, that isn't feeding into something else. It's just feeding into the product. And one other thing is there are failures that don't actually fail a job, but you've somehow created corrupt data. So it's really important to have some sort of check that makes sure the data hasn't changed too much, that it still looks like it should. Okay, so getting into workflow engines a little bit now. Almost everyone, and at least in my experience, maybe this isn't true for you, get started with using cron. And it looks something like this. At 1 a.m., I'm going to import all my data. At 2 a.m., I'm going to run some really expensive query. And then at 3 a.m., queries B, C, and D are consuming the data from the really expensive query, and they're producing some sort of analytics data set or production data set. And this can break a couple of ways. But the most common one is that the step at 1 a.m. fails, the step at 2 a.m. runs anyway, the step at 3 a.m. runs anyway, and now you don't know what happened. You're kind of, well, I see the last step failed, but you have to go back through and figure out what went wrong. This doesn't scale past, I'm saying, about 10 jobs. And it really doesn't scale if you have more than a couple people, because once you have 10 people all editing the same cron tab entry and trying to change things around and figure out this dependency graph in their head and the cron tab, you're in a lot of trouble. So you're working with cron, and you're like, okay, I realize this is a bad problem. Let's do something about it. And I think there are two possibilities. The first is that you say, all right, a workflow engine can't be that hard. I'm just going to write it myself. And if you do step 1, you're probably going to do step 2 anyway, which is you're going to look out there and see what's available, because you realize that, hey, writing a workflow engine actually is really hard. And you figure out which ones are available, and you probably try all of them. At least that's what I've always done, because you don't really know what the best option is. There's so many options. There are Hadoop-specific workflow engines. There are general-purpose ones. There's not roll your own, but use a library and try to shoehorn it into an existing application. And it's really shoehorned, because I feel like every time you try out one of these workflow engines, you had all this stuff that was mostly working, and now you try to make it run inside the workflow engine, everything breaks in 10 different ways. And a month later, you finally get your workflow to run again. So here are some things you should be thinking about when you're trying to figure out which workflow engine is right for you. How do I deploy it, and how do I upgrade it? That's both the workflow engine and the workflow definitions themselves. How do I test it? How do I test an upgrade? How do I test a new workflow? Because, like I said, this application might run fine from my laptop, but I try to run it inside the workflow engine and it starts breaking for, you know, you're in Java class path hell, or you have file handle limits, who knows. once you have something up and running, how do you detect failure? How do you, when something fails, how do you debug it? How do you find the logs? You might think this is a silly thing, but you know, logging is easy, but hopefully I'll show you there's a pretty wide range of debugging options based on which workflow engine you choose. Let's talk about that partial failure I said where you run over half the data. If you run over half the data and you need to now rerun the workflow and everything downstream of it, how do you do that? Is it easy? Is it manual? Is there some way to automate it? Or conversely, if I now have 6 months worth of intermediate data and I want to add a new column to the data set, how do I rerun, you know, the past 6 months of data so that I have everything I need? I think this second to last one, a lot of people overlook. How do you load data to and from a relational database? I think most people start running, most people are either running like MySQL or Postgres on their front end, or they're taking data and loading it into Vertica or Redshift on the back end. And it can be a harder problem than you might think. And lastly, how do you manage or maintain a set of similar tasks? So you want to do the same thing on these 10 different data sets. How do you do that? Sorry about the light gray here. How do you, or let's talk about Uzi first. This is just, I have an architecture slide for each of the workflow engines I'm going to talk about, Uzi, Azkaban, and Luigi. Just to give you a flavor of like how complex they are, how many pieces are talking to which pieces. Basically, there are three main parts in Uzi. You have a server that is responsible for launching jobs and also detecting when data sets arrive in HDFS. You have a client, which is responsible for both the dotted line there, uploading data to HDFS. So with Uzi, you upload your job definitions to HDFS, and then you use the REST API to submit your job to the Uzi server. And then the third part is it's not real clear here, but you have a MapTask launcher for every single workflow that you run. So what Uzi does is it says, okay, you want to run a MapReduce job? All right, I'm going to submit a job to the Hadoop cluster, and all that's going to do is the job's going to run on the Hadoop cluster as a single MapTask, and it's going to spawn the actual job that you want to run. So there's this level of indirection. So what's, in my opinion, hopefully objectively, the good parts of Uzi? You have fantastic community support. Basically every single Hadoop distribution comes with Uzi, and it's part of the Apache Software Foundation. You have lots of resources online. That also means it's integrated with a lot of different software. Hue, which is a front end to Hadoop. Hue stands for the Hadoop user experience. Cloudera Manager, which is basically software that helps you deploy different pieces of software more easily. And Apache Ambari, which is similar to Cloudera Manager, but an open source project. What else do we have? HCatalog integration. So HCatalog is this system that interacts with Hive. You don't really need to know too much about this, but basically, instead of polling the file system to figure out when data is available, you can subscribe to JMS messages that HCatalog publishes when data becomes available. So your Uzi workflow will run as soon as the data becomes available. You have SLA alerts. This is a new feature in Uzi 4. You can say, all right, I want this workflow. This workflow should run in 30 minutes. And if it doesn't run in 30 minutes, send me an email. You have vast integration with the entire Hadoop ecosystem, Pig, Hive, Scoop. The documentation online is super detailed. If you want to use the Uzi REST API, there's tons and tons of documentation on every single endpoint, all the arguments, all these things. And it has the feature I was talking a little bit about, that I was talking about before, where it launches a map-only job with a single map task that then spawns all the other jobs. So that means that you don't need a fleet of machines to kind of act as the launchers for all your tasks. Basically all you need is the Uzi server and the database backing it, and then you can run as many MapReduce jobs as you want. With that said, launcher jobs as MapTasks is also a bad thing. It adds complications, so if you want to debug a job that failed, you now have to go about 4 links deep in the MapReduce API, or the MapReduce UI, in order to find the actual logs that describe what happened in your job. It tends to hurt cluster utilization because you have all these map tasks running that are basically doing nothing other than asking the job tracker every 10 seconds if the job that they launched is finished or not. And I think there was one other thing, but I can't think of it. So the UI to Uzi is also pretty horrendous, but as I said, there is Hue, and there's also a project out of Foursquare called Uzi Web that gives you a much nicer front end to Uzi using the API that Uzi exposes. The barrier to entry to Uzi is extremely high. We would have to sit down with a developer and basically walk them through, coding out how the definition for this workflow, and it would take a good day or two just to define the workflow, and then you have to run it, and that's another whole complicated thing. Finally, setup, not finally, but also setup. It's not just a one button install. You have to download this ext.js. You have to set up the Hadoop proxy user and the name node and the job tracker. And you need a relational database. And last of all, some people love XML, but I absolutely hate it. Or let me rephrase, humans shouldn't have to use XML. Yes? Yeah. Yeah, so there's a command line tool that basically is a Java application that hits the API, and the API is really good, so that seems to work pretty well. Yeah, I have you can't really see it, it's really faded, but that's the Uzi UI. It looks like something from Web, I don't know, 2.0, but failed. And it's also really unresponsive. There's all kinds of AJAX calls without telling you that something's happening, and then you click 3 times, and now all of a sudden you've issued 3 database queries, and it's like killing the database. Anyway, in terms of XML, that also means there's a lot of boilerplate. So this is what hello world looks like in Uzi, and really all you're trying to do here is invoke a main method. Yeah. So that's pretty much all I had to say about Uzi. Azkaban is a open source workflow engine written by the folks at LinkedIn. As I said, I used the first version of it. I spent some time with Azkaban 2, and I don't think there are a whole lot of major changes. I'll try to point out what they are, but hopefully I can still give you some objective points about the Azkaban workflow engine. So architecture-wise, it's somewhat different from Uzi in that you still have this centralized server, but instead of running jobs as map-only MapReduce jobs, you have these Azkaban executor servers, and they are the ones that are submitting the jobs to the Hadoop cluster and managing the state of if the job is finished or not. And it's backed by MySQL, and I think it can also run with either Derby or H2, I forget which one. And the other thing that's worth pointing out in this architecture diagram is that I have Azkaban client there in quotes, and that's because Azkaban is very UI driven, so you have to go to a UI and upload a workflow, go to a UI and run a job, go to a UI and schedule a job. There are some options to basically run the same request as the UI would run via the command line, but it doesn't let you do things like schedule a job, or if it does, it's a little more complicated. So with that said, the good things about Azkaban, you have a great UI. You have things like DAG visualization, task history. You can easily click through to all the logs for any job anywhere. You have this plugin architecture, and that gives you access to all the stuff in the stack, the pigs, the hives, and also an integration with Voldemort. And one of the things that LinkedIn likes to point out about this plugin architecture is that it lets you run multiple versions of Hadoop within the same deploy of Azkaban, because you can have a plugin for version 1, a plugin for version 2, and everything like that. It also has SLA alerting. It has a really great HDFS browser, so you can click through from a job to its output and then click a button and get the first 10 records. It converts Avro files to JSON so that you can view them. It has user authentication and authorization. And it also has auditing. So if someone goes and changes a job, you can click through on the UI to see when it was changed and who did it. And there's this really cool feature that has not yet been merged called the reportal, which is basically a quick version of a workflow. So instead of uploading a workflow to the Azkaban server, normally you define a Azkaban workflow as a Java properties file that says, okay, this is my main method, this is the type of the job, these are the dependencies, things like that. And then you bundle jars with that properties file and put it in a zip file and upload it. So the reportal lets you get around that. If you just want to run a Hive query or a pig script, you go to the reportal and you can paste in your query, and the job gets automatically created, and you can say, run this once a day, email me, etc. So hopefully that gets merged soon. I think that'll be a great feature. This is maybe not the best screenshot, but to give you an idea of like what the Azkaban UI looks like, it's definitely much better than what Uzi comes with out of the box. There are a few things that are not so great about Azkaban. You have this missing notion of data dependencies. So if you think back to that cron example I have, where at 1 a.m. you import log data, at 2 a.m. you run a expensive query that goes over the log data. You don't want that job at 2 a.m. to run unless the log data is available. And you end up defining, if you want to represent those dependencies in terms of task depending on task, that can become a very complicated thing to represent, because you might have your log ingestion that runs every night, and then you might have 300 things that depend on it. And now you have to, those 300 things that depend on it have to know the name of the task that does log ingestion. So it's much nicer to be able to represent this job should run when this data is available, kind of thing. Another thing, the executors run on separate machines. It's not part of Hadoop. But maybe with Yarn, which lets you schedule arbitrary jobs, you'll be able to run your Azkaban executor services as on the same nodes as your Hadoop cluster. In terms of community, from what I've seen, I'm kind of a lurker on the Azkaban list. It seems to be mostly used by LinkedIn. And version 2 was basically a code dump a year after the version 1 code dump. So there wasn't like a whole, it's not like a Apache software project where you have people from all kinds of different companies collaborating on it. But with that said, the mailing list is super responsive. If you have a question, you send it off and you'll probably hear something within a day or two. And then for Azkaban, I had a couple things that were both good and bad. So you're defining your jobs as Java properties files. This is definitely simpler than XML, but it's also a little bit, there are some things that are hard to represent as Java properties. Or if you have to worry about escaping variable names or things like that because there are escape rules in Java properties files, or you can't have a value span multiple lines, things like that. Web uploads, deploys, that might be like awesome for you, that you go into the Azkaban UI and you just upload, upload the zip file that says, okay, this is how this is the name of the job I want to run. For me, I think that's a terrible idea because you're basically, I could have built that code on my local laptop and not checked anything into source control and uploaded it. And first of all, it wouldn't be me doing that. It would be someone else. But I would be the one debugging it. And I don't know what's running. It might be great for a lot of people, but for me, I don't think it's good. And it goes along with running and scheduling jobs. If you want to integrate with configuration management, so you want to have a definition of all your workflows, and you can have a staging version and a production version, and they're identical, all in like Puppet or Chef or what have you. It's really hard to do with Azkaban. I did it when I was working at Adconian, and it was mostly possible, but it was also a lot more complicated than it should have been. So, last workflow engine I'm going to cover in any depth is Luigi, and Luigi comes from Spotify, and we have some Spotify folks here in the back. If people have questions afterwards. Also a good time to point out that I feel really bad about saying anything negative about anyone's workflow engine, because I know there's been a lot of hard work put into everything. I'm just trying to, give a fair overview of what we have. Okay, so here's the Luigi architecture. You have a centralized scheduler, and you have a lot of workers, and the workers communicate with the scheduler over a JSON REST API. And each worker has a copy of the code base. In Luigi, you don't define your tasks as properties files or XML files. You actually write a little Python class to describe your task. So each worker gets a copy of the entire code base, which is a copy of all of the tasks that it needs to run. And each Luigi worker talks to HDFS, and it walks the workflow DAG, and it says, for each task, does the output exist yet? And it uses that information that it finds as it's walking the DAG to figure out which tasks need to be run. And then after it walks the DAG, it communicates with the scheduler, and the scheduler acts as a locking mechanism so that you don't have two of the same jobs running at the same time. So the Luigi worker talks to the scheduler and gets back some work, and then it actually runs the job via MapReduce or Hive or what have you. So what's good? Task definitions are code. If you need to do a for loop for some reason, you can do a for loop. You're not like trying to write a for loop in XML. Tasks are idempotent. Idempotency means that you can run the task. You can run the same task again, and it won't break anything. It'll say this task has already been run, and it'll gracefully exit. So that's a super helpful property. Workflows define both the data dependencies and the task dependencies. So what I was alluding to before, if you have like 300 tasks that all depend on your log ingestion, there's a relatively easy way to represent that. I think the community is growing. It's by far the easiest code base to hack on, and if you need to if there's some feature not in Luigi and you want to use it, or you need this feature, it's pretty easy to add. It has a nifty Postgres integration, which when I was at Foursquare, we got this to work with loading data to both Redshift and Vertica. Now the bad. So it's missing a few key features. One that stands out is pig support. I think honestly it'd probably take about a day to add this feature, but no one's gotten around to it yet. The deployment situation is a little confusing. It took us a long time when I was at Foursquare to figure out how to do the deploys correctly, because you have to get a copy of the code base distributed to every worker, but you also don't want like half your workers running one version of the code base and the other half running another version, or if that does happen, you want to be able to easily tell when a job fails which version of the code it was running. And even though I said it's like the worst thing ever, deploys in Luigi use cron, which is also a little counterintuitive. The Luigi has a great visualizer, but it doesn't scale to tens of thousands of nodes in your dependency graph, which it doesn't take much to get there. And it's also not backed by a relational database, and the scheduler does persist its state when it gracefully shuts down, but if it doesn't gracefully shut down, you've lost the state, and you can have some data corruption issues if you bring back up a new scheduler, because all the workers will try to rerun jobs they're already running. And lastly, when Luigi walks the dependency graph, it checks for every task if the output exists. And the way that it does that is by shelling out to the Hadoop command. And it says Hadoop fs-ls output file. And that there's a lot of JVM overhead to do that. You're talking like 3 to 5 seconds for each task when you're walking the dependency graph. And there are some ways around this, but the basic, the batteries included implementation does have this limitation. So I put together some comparisons of these 3 workflow engines in my own words. I tried to be as objective as possible. But the caveat at the very beginning, I have contributed to both Azkaban and Luigi. You can see one of the things that definitely stands out is the code complexity. You're talking 2 orders of magnitude difference between Luigi and Uzi. So Luigi is super easy to hack on, but if you find a bug in Uzi, you better find a workaround. It's like super hard to get familiar enough with the code base to fix it. This is a lot of recap of what I talked about before. There's a little bit more on this page. Property configuration can be a total headache if you want all your jobs to run with some production database password. You might think that's super simple, but you don't want to hard code that into all the jobs, because the next time an employee leaves and you have to change that password, then it can be a huge pain. Reruns are also an issue. Uzi has a command line interface to rerun jobs. I have to say, this was a couple versions ago, but I could never get the rerun stuff to actually work. Azkaban has a nice feature where if you have a 10-step long workflow and the first 8 steps succeeded and the last 2 failed, when you rerun the job, it'll only run the last 2. And Luigi, since it's idempotent, it won't rerun a job unless you explicitly delete the output of that task. And other considerations, if you're using, if like security and authorization are super important to you, Azkaban has auditing. It has you can define all your user authentication in an XML file. Uzi has Kerberos and the equivalent of Hadoop simple. Whereas Luigi, you're running jobs as a Linux user. So if you want to secure if you have a secure Hadoop deploy, then you can take advantage of that by just running your jobs as particular Linux users on your gateway machines in your Hadoop cluster. There's a bunch of workflow engines I didn't get to go through. You might want to look into these. They're not as popular as the 3 I've mentioned. Some of them are popular, but in a more general purpose setting. For example, if you use Spring everywhere, then Spring Batch might be a great solution for workflow engines for you. Okay, so now I'm going to take off my objective hat and talk a little bit more about like my personal feelings. Maybe give you an idea of which workflow engine I think you should use if you haven't figured it out already. All right, so first one. I really like that Luigi in particular is a scripting language. Because what happens a lot of times with all these other workflow engines is that when you want to run a one-off job to debug it outside or test it to make sure that everything works, you actually end up writing a bunch of scripts to run your jobs anyway. And why not just use a scripting language for your workflow engine at the beginning, and then you get all these features for free. So in Luigi, when you define a task, you can list out parameters, and then those become available as command line options when you're running your task automatically. And what we found at Foursquare is when we moved to Luigi, people, instead of writing these custom scripts, would actually, as they were developing their MapReduce job from the beginning, would write a Luigi task defining the MapReduce job and its dependencies, and then because it was easier to run your job that way than it was to run it without Luigi. And you can also do things like you you want to represent a 7-day data dependency. Well, you just use a for loop and you say, all right, it depends on these 7 days, and you return that in the requires method of your task. Whereas if you want to do something like that in Uzi, it's going to be a lot more complicated. Item potency, I think, is super important. If you by default, if you try to run a MapReduce job and the output directory already exists, your job's going to fail. So it can be really misleading if you do a rerun and all of a sudden something fails because the output already exists. And so the solution that a lot of people do is the first step of their MapReduce main method is to delete the output. And that's like super dangerous, because what if you rerun this job that you didn't mean to, and it like deletes a data set that spanned a year or something like that. So it's really nice to have item potency to kind of take care of this issue for you. I alluded to it earlier, what you see is what you get. When we started out with Uzi, we had all these jobs that were working, and then we took them and ran them inside of Uzi, and they started failing for various reasons. Class path issues. You had to massage the job so that you could propagate properties in certain ways. It's really nice to be able to run your job the same way in development as you do once you're in production. And that's something that you could probably build the right tools to do that in Uzi or Azkaban, but it's kind of baked into Luigi and easy to hack on. Pretty much any workflow engine you choose is not going to have all the features you want. That's why I said in the very beginning, you're going to take your existing workflows and you're going to try to shoehorn them into whatever workflow engine you pick. So being able to hack on it, I think, is super important. And to kind of give you an idea of my bias in terms of things that I think are less important, high availability. You know, if the workflow engine crashes on a Saturday, I'm okay with, you know, within 6 or 12 hours intervening and bringing up a new instance of the workflow system. I don't really care about supporting multiple clusters. I'm not running like 10,000 or 100 clusters, so I'm running 2 or 3, so I can bring up an instance of the workflow scheduler for each cluster I'm running. And I've never used the Hadoop security features, so if that's a high priority for you, then there might be all kinds of issues with Luigi, and you might want to use Uzi because it has that stuff built in. Last slide, just some like words of wisdom in terms of best practices with whatever workflow engine you choose. I like the idea, and I haven't done this in a while. We did it at my previous job, but I like the idea of versioning data sets. So let's talk about you have some data set that has 9 columns in it, and you want to add a 10th column. What you could do is you take Joe's data set and you delete the past year of data, and you rerun it, and you produce the new data with 10 columns. The other option is you version your data set. So you have Joe's data set version 1, and that's like encoded in the URL of your data in HDFS or S3 or wherever you're storing it. And then when you want to do backfill, you are writing to a different directory. And after your backfill is done, you can clean up, garbage collect the old data. This is one that always bites everyone. So you set up monitoring for when a job fails, but there's this other type of failure which is basically the job doesn't run. So you need to monitor, say you like hit Graphite whenever a job finishes, and then you look for the fact that a job hasn't finished within the past 36 hours, and you fire an alert if that happens or something like that. And you hear a lot about continuous deploy for websites, for user-facing features, and I don't think I've ever heard anyone talk about continuous deploy for Hadoop. And we did an experiment where we had continuous deploy for Luigi at Foursquare, and I think it's a good practice, but you also need a lot of testing in order to really pull it off well. So if you have like a staging cluster that is a subset of the data and you can smoke test your entire workflow, I think continuous deploy is great. And I'd like to bring up that as a conversation point. I think that it always stinks when you have code that you committed 3 months ago and it finally gets deployed and you're working on something completely different and now you have to go back and debug it, right? You want something to be out there the next day so it's still fresh in your mind, you're not doing these context switches. Let's see, resources. I'll post the slides online and so you guys can grab these links. I found a few talks on each of the frameworks. They're all pretty good. And that's all I have. Thank you. And I'm happy to answer questions.